Hey guys, people of Earth, and those of you that are extraterrestrials. So sorry, that was Siri. Anyway, um, so you have been working with decimals the last day or two. And the reason we're switching from fractions to decimals is because this unit is called bits and pieces. So, um, it's just another way of talking about parts of a whole. Okay, so the first thing that you need to know about decimals is that every decimal number can have, or it has, a bunch of invisible zeros behind it. In fact, you can put as many zeros behind a decimal number as you want, and it's going to maintain the same value. It's really important, though, that you realize this only works with decimal numbers. So any of these, I could just put zeros all day long or for the rest of my life. If it's 123 thousandths, I could add as many zeros as I want, okay? The next thing you need to know is that every number, every whole number, let's say we have the number 12, it has an invisible denominator of 1, meaning that I have 12 pies. Each of the pies is only one piece, and there are 12 of those one-piece pies. So essentially the same thing as 12 pies. So far our rules are, just a reminder here, every decimal number has invisible zeros after it. Every whole number has an invisible numerator of 1. And the third rule is that every whole number also has an invisible decimal after it. So I have 12 or I have $12.00. These are the exact same things. Okay, so that's just some important number sense rules that you need to know. I would make a note of those if you could. So now that we're dealing with decimals, we're going to be adding, subtracting, multiplying, dividing decimals. And there's something really important you need to know. So think about a snowman, okay? Cute little snowman. He's got a carrot for a nose. He's just as cute as he can be. And he always has some what right here in the middle part. What do we always see? We always see some cute little buttons, right? And the buttons are always in a nice little row. And that's how you need to think of decimals. If you're comparing decimals, like I have here, 567 thousandths, right? Let's say I need to compare it to another number. Let's say I need to compare it to, something like 500ths. The most important thing is to realize that you have to line up your decimals. So if I move this guy over here, the most important thing is that this decimal is directly in line with this decimal. Now I can copy the rest of the numbers, and now I can compare it. Okay, so just to make it a little easier, I'm going to draw a box here. Oh, it's not going to let me fill this box. Shape color, fill color. Let's fill it in. No, this one's filled in. Okay, we'll use this one. All right, so is that movable? Gosh darn it, that's not even movable. You are a waste to me. You mean nothing. All right, let's try something else. We're going to insert a shape, okay? And this one for sure will be filled. And now we're going to come back over here and we're going to draw. So once again, let's say I have, I don't know why all of these have 0 as the whole number, but for some reason I'm doing that. And let's say I do a really good job of lining up my decimals. Oops, 009. Now I need to compare them. So what I need to do to compare them is first turn off my drawing tool. Turn that off. Stop drawing. Oh, curses. Why is it is working. Okay, sorry. I'll be right back. Everyone remain